Unit 8, Day 2, Slope Point Form of a Line. Recall that last class we determined the form of a line by determining the slope and solving for b using the slope y-intercept form, which we know to be y equals mx plus b. Today we're going to investigate another way of writing a line, and that's called the slope point form of a line. So here's the slope point form of a line. M represents the slope, and P and Q are coordinates of a point that this line goes through. So it's slightly different from the y-intercept slope form that we're used to because it has b, which is the y-intercept. This form of the line does not have the y-intercept in it. It simply has a point that the line goes through. Example 1. Determine the equation of a line y equals mx plus b with a slope 3 and goes through -3, 5 using the y equals mx plus b approach and the slope point approach. So let me start with doing part A, the y equals mx plus b approach. So we can plug in 3 for our slope. And then to solve for b, let's plug in -3 for x and 5 for y. And we're left with 5 equals to -9 plus b. We can bring 9 to the other side by adding 9 to both sides. These cancel out, and we're left with 5 plus 9 equals b. So 14 equals b. And now we can plug everything back into the y equals mx plus b form. So y equals 3 is our slope, and 14 is our b. So now let's do the exact same thing, only using our slope point approach. So our slope point formula is y is equal to m bracket x minus p plus q, where m is our slope and p and q are the coordinates of a point that the line passes through. So again, we can sub in 3 for our slope, and then we can sub in -3 for p and 5 for q. And now let's isolate, and now let's simplify this a bit. So we can do y equals 3 bracket x plus 3 plus 5. And now to get this into y equals mx plus b form, let's distribute 3 inside the bracket. So y equals 3x plus 9 plus 5. And we're left with y equals 3x plus 14. So again, you can see we've come up with both the same final equation, but 2 different ways to get there. Example 2, use the slope point approach to determine the slope y-intercept form of a line that has a slope of 2 and a y-intercept of 5. So the slope point formula is y equals m x minus p plus q. We can plug in 2 for our m. And if the y-intercept is 5, we can create a point of that. We know that that is a point on the line. So let's plug that in for p and q. Finally, let's distribute that 2 inside the brackets. And there is our final equation of the line using the slope point approach. Next example, let's do the exact same thing, only this time the line has a slope of 2/3 and passes through point 1, 5. So y is equal to mx minus p plus q. Let's plug in our slope, and then we can plug in 1 and 5 for p and q. Now let's distribute our slope inside the brackets. And finally, to combine these 2 terms, we need to make them into fractions with the same base. So I'm going to get them both to fractions out of 3. And finally, we're left with y is equal to 2/3 x plus 13/3. Our final example is asking us to find the equation of the line that passes through the following 2 points. So again, our slope point form is y equals mx minus p plus q. We don't know our slope yet, but we can figure it out using these points. So slope we know to be delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. So this will be my x1, y1, and this will be my x2, y2. So let's plug those values in. So y2 is negative 1, minus y1 is 7, all over x2, which is negative 3, minus x1, which is 2, which is equal to negative 8 over negative 5. Negative divided by a negative is just a positive, so we bring it down to 8 over 5. So now let's plug that value that we just found for the slope into this equation, as well as any of the 2 points. So I'm going to pick the x2 and the y2 for my points. So negative 3 is going to be my p, and my q is going to be negative 1. Now let's simplify this a bit. So we get 8 over 5 x plus 3 minus 1. Now we need to distribute the slope inside the brackets. So we get 8 over 5x plus 24 over 5 minus 1. Again, to combine these two, they need to be fractions with the same base. So we need to convert this 1 over 1 to 5 over 5. And finally, we're left with 8 over 5x plus 19 over 5.